Hi, welcome back to Moose and Chemistry. Today's lesson is on balancing word equations, lesson 2. Today we're going to balance 2 or 3 equations. Let's start off with a simple one. And we'll take zinc and lead. And this will be lead 2 nitrate. There's our Roman numerals. Okay. React to form zinc nitrate and lead. Alright, so this is our word in equation. So now, see this and? That and means basically plus. React, right there, that means our yield sign. Form, right here, tells us that we're making our products. Okay, so these guys here, of course, are our reactants. And remember that reactants make products. So zinc and lead, which is normally 4, but this is telling us it's lead 2. So that'd be NO3 nitrate to the second power, because that's plus 2. It's a minus 1 charge. React, and of course zinc by itself would be 0 to form zinc nitrate. Zn, and zinc is in group 12 anyway, so it's going to be Zn, of course, NO3 2, so that's a minus 1 plus 2 charge, plus free lead. In this case, it's going to have a 0 charge. So when we look at this, our equation is already balanced. So that's our first problem. Let's look at another one. Let's clear these drawings. Okay, we're going to clear these, and let's try a harder one, kind of, well, it looks harder. Sodium phosphate. It takes us a while to write these guys, so just be patient with me. Okay, sodium phosphate and calcium chloride. Okay, react to form calcium phosphate and sodium chloride. All right, now we need to write this equation. Remember that this is a plus sign, and this means a yield sign, and that yield sign tells us the direction of the reaction. So sodium phosphate, sodium's Na, phosphate is PO4. Knowing that phosphate has a minus 3 charge and sodium has a plus 1 charge, we do the crisscross and we put the 3 there. And the and sign is a plus sign, so this is calcium chloride. Again, chloride has a minus 1 charge, calcium has a plus 2 charge, so we crisscross again. React to form calcium phosphate. So remember that's a plus 2 for that. PO4 minus 3. So we're going to crisscross, put a 3 here, put a bracket here, and put a 2 there. And sodium chloride, NaCl. Well, when we balance this, we know that we're going to have to put a 6 in front of here, a 3 in front of here, and a 2 in front of here. And then our equation is balanced. Let's take time to look at one more of these type of problems. So let's go ahead and clear these drawings again. And we'll clear these, and let's try this one. Let's try something a lot more simpler. Let's say aluminum. Some people call that aluminium. And hydrochloric acid. Okay. React to form potassium chloride. Whoops. Sorry, to form aluminum chloride. I was looking at another problem at the same time. And that kind of happens when you're doing all these videos. So we'll forget that one for now. And hydrogen gas. Okay. So let's go ahead and write the formula. So we have aluminum plus hydrochloric acid And I don't know where that mark came from, but we're going to get rid of it real quickly, probably from my hand. Yields aluminum chloride. Remember, that's -1 plus 3. That's 0, -1 plus 1. These are just oxidation numbers. Crisscross plus hydrogen gas. Okay, so we're going to have to put a 3 in front of there, a 2 in front of here, a 6 in front of here, and a 2 in front of the aluminum. And that's balanced. And since we talked about potassium chloride, I guess I'll go ahead and do that problem. So I'm going to clear all drawings real quickly, and we'll put that one in kind of as, like, think about it as like a bonus. So let's see, potassium. Okay, we have potassium metal and chlorine gas combine to form potassium chloride. Now we can say potassium chloride. Okay. So potassium metals K, 0 charge because it's by itself. Chlorine gas, diatomic, remember the 7 diatomics, combine to form potassium chloride. That'd be KCl, because it's -1 plus 1. And so we're going to have to put a 2 here because of the chlorine's 2 there, and we need to put a 2 there. So I hope you guys understand that writing word equations is really not that difficult. You do need to know your oxidation numbers, you do need to know your element symbols, and your polyatomic ions. Well, you guys have an awesome day, and we'll see you back at Moose in Chemistry.